Myself, Dr. G. Suganya, working as an associate professor in Vellore Institute of Technology, Chennai. And thanks to so actually the topic for today, which we have discussed, is from dataset to deployment. Doesn't mean anything more innovative or over the research proceedings. This is a simple concept, and this is on a beginner level, wherein we are going to discuss what a data set means and how to create a data sets of our own, and along with that, once the data set is formed, how to make yourself comfortable for the analysis and the pre-processing working on the data set to make it ready for modeling. Then once the modeling is done with the available machine learning models, how to take it to a live environment to be presentable to the client is what is the point of discussion that is going to be today. When I was discussing about the data set, okay, that I can take and present to you all. So I thought the available data sets, use of available data sets may be readily available online, and hence I was thinking of a concept. 2 days back, when we were discussing in my family about painting my house, okay, so we came to a conclusion. We were discussing about the quality of the paint, and we were thinking of to paint our house. So while the discussion is going on, so we asked all our family members, actually it is a joint family, so we asked all our family members to give the suggestions, okay, on how what kind of paint you want, and what is the color we are in need of, right? So all of us are trying to give, all of the family members are trying to give their own opinions, okay. So what are such opinions? They were discussing about brand, what is the type of paint that we can use. So whether we go for exterior painting or interior painting, the type means we have a lot of different things, no, like emulsion, you have weatherproof paint, you have paints that glow, and all those things, and what are the different color combinations that we can mix up and how to do, okay. All these things people were talking about, and once this discussion is going on, we thought this is not at all enough for us, and hence we called off a painter, right? So the painter came in, and to our surprise, it is not the points that we have discussed alone. He has given a lot of points from his side, right? So one is the size of the question he asked is, what is the size of the house, and what is the time period that we permit him to work? How many coatings are we in need of, right? So double or triple coating. And how about the surface finish? Whether we need to close all the blocks and or just it is a overlaying painting.
This conference will now be recorded.
How many do? So these are the different questions that the painter has asked, and finally all of us will got into a confusion, right? So it is on a different perspective that we have thought about that painting. Now it came to a different perspective, right? Now suddenly, since a big confusion is going on selecting the different brand, what kind of thing, and what is the how many coatings we are in need of, how many days can we permit, okay. So my son came with an idea, right? So he gave me an idea, okay, to create a data set of this kind, okay. So what is this? It looks like a relational database, right? So it is very similar. Normally you can store this. When you have a data structure of this kind, we call this as a matrix. You know that a matrix is a two-dimensional data structure where you can store data in this format, right? So having the values of all the attributes that we were talking about, either by the family members or by the painters, we have list of attributes segregated alone, okay. Every attribute, if you take, if I take brand, okay, we have n number of attributes. We have Nippon paints and so many other things. Those come under brand. Whether if I come to exterior or interior, only there are two options. Either we go for exterior paint or we go for interior paint. No other type of paint is there, okay. So depending on the column, the number of values that can come in the particular cell may vary, right? Okay, we're coming on to the color, okay. So it may take values like 1 or many, right? So 1 represents same color, many represents different color, okay. So it is all individual's perspective. Now what my son did, he passed on the sheet to all the people of the family and they asked them to fill. Okay, so who will fill this sheet? Everybody at home. We all have filled up the sheet along with the painter's decision on this. So altogether, this data sheet is now ready, right? So this is what is the data sheet that is currently available now. Okay, now once we thought this is over, then our head of the family come in. Okay, so he asked, okay, you all were discussing about so many things, you called a painter and you are discussing about it. What about the cost that will be incurred for this painting, which we have never thought about? Okay, because being a person who is just thinking of this, we never thought of how much will be the cost that is for painting the whole house, and whether we'll be able to make it out or not. All those things we may not have been thought of. Okay, so that's what is the requirement of head of the family. So what we did, we went on trying to go for adding a final column called cost, and we try to calculate depending on the values which we have given. We have say for a brand, whether it is interior or exterior, the type, how many colors you need, all those things we googled and we found how much would be the approximate cost. Okay, so these data are being added with the actual cost given by the painter also. Okay, all those things are went off, and finally we are able to arrive at one data sheet which has values of this kind. Okay, I'll be switching between the screen, just bear. Ma'am, am I audible and the screen is visible?
Yes, ma'am, you are audible.
Yeah, okay. So now this is the data sheet finally we arrived at. Okay, this is a sample data sheet. Okay, so we have filled up some n number of 15 persons have filled up the contents of this sheet. We have brand, we have exterior, interior values, type and color. You could see some of the values are not filled up. For example, these are left, these are left, these are left. Doesn't mean that they don't want to fill. Like sometimes we may be in a confused mood, right? So we don't know whether to use exterior or interior painting. So we don't want to put our decision firmly. So in that case, we may be leaving the particular cell as empty. Okay, that emptiness doesn't mean empty value. So it should be filled up with appropriate value according to the prevalence of this data set. That's what it means. Okay, so similar to this, we have this color. So I may not be interested in giving my own opinion of to have same color or many colors. So I'm leaving some of the cells as empty, right? So that's how it is. Let us continue. So once this is done and all the data are being created, now if you look at, that's what we have, we call it as the data set. What we did till now is the creation of the data set, right? So once this is created, let us try to understand what are the components of this data set. Okay, so you have, this is just a matrix, right? So nothing more than that. It is a two-dimensional matrix. All the data sets that you are going to work with machine learning only will be of this format, which is of rows and matrix format, right? So what is this rows and matrix? Sorry, rows and columns. Okay, it's a two-dimensional matrix. Again, you can think of it to be adhering to your relational database structure. Okay, we know many languages that we use to work with the relational database. It might be Access, it might be your Excel, it might be your Oracle, PHP, MySQL, all the different things. Even if you work with unstructured data, you may think of, right, in machine learning, it's not only the structured data that is going to be used. Structured data, really we mean the data in this format, right, in rows and column format. We also work with unstructured data. For example, if you are given with a passage and if you want to find out how many verbs are recurring, how many nouns are recurring, how many such things. People are talking about natural language processing, right? Again, the concept is that depending on our requirement, we have to work on the passage and you have to bring down a data set of this kind. Okay, so the machine learning models or any mathematical, any computer models can only work on your numerical data, not anything more than that. And hence all data whichever we have at our hand has to be converted or confined into a two-dimensional matrix which is of interest. Now, looking at what column represents, okay, so what are these things? Brand, exterior, interior, type, color, size, all those things. What does it correspond to? Our domain of interest is painting. So to that painting, our domain of interest, what are the characteristics that it possesses? Okay, so the domain which we are choosing on a particular period, we try to identify what are the characteristics or the features that contribute to that domain. That becomes your columns, right? We know that for painting, we are in need of brand. We are in need to understand this color, how many colors we need. We are in need to understand how many days are we going to permit. We are in need to understand how many persons are we in need of. Okay, so all these things are going to contribute to the domain of interest, which is painting. If you take healthcare, okay, for example, hospital management, the attributes may differ, okay, but anyway, there would be a finite set of attributes. But this attribute, if you see, you may have a question of whether it is finite or infinite. Not necessarily to be finite, okay. In this example itself, we have seen that the cost is an extra attribute added by the head of the family. Likewise, as and when the domain experts comes in, or as and when you try to add on your experiences, we have there is a provision to add you the number of features. Okay, so the now features will get added depending on our requirement, right? So having understood, what can you do with this? Okay, so all relational operations that you do can be done with this data creation, with this corresponding two-dimensional array. Okay, you can create a table, you can insert a row. What row indicates? It is the experience of one person, right? So if you fill up brand, exterior, interior, all those one row, first row, it is your experience. If your brother is filling up the second row, it is their experience. If the painter is filling the third row, giving his own option, that becomes your third row. Likewise, this experiences grows as and when we have number of people at our home. Okay, so like how as we grew up, our experiences grow, and depending on the number of experiences, our maturity level increases. So as and when the number of experiences gets added to this data set, we'll end up with a matured data or data set which can give you optimum value or a better result. Okay, now, having understood this, what are the operations that you can do with this data set? That's the next question. So, we are not talking about machine learning. These are all general understanding. All these things will directly map it to machine learning. So, now whatever activities you do with general relational database, you can create a table of this kind. You can add columns, right, which corresponds to your attributes. You can add the values. Okay, so insert into table name values of will write, right? So that creates a row, which is nothing but an experience or an instance in machine learning term. And then you can modify the values that resides here. Okay, so it is mutable data type only. Okay, so you can change the values whichever you are already having. You can drop certain columns. All the activities you can group by based on a particular attribute, and then you can perform operations. So all those which you can do with the relational database is possible in this data set also, right? So having done this, now this data set is what is at our hand. With this data set, what are you going to do? Okay, so this data set, as we have seen, okay, so it is not necessary to be complete always, right? So because it's just an experience that we are collecting from all the people that is in and around. So sometimes it is like it is not only the human being who is going to give the input. It may be sensors. For example, if there is a sensor, so you would have heard about the blast that happened in NLC. Okay, so so many questions are arising at this point. If the boiler is about to blast, okay, so does it not have any controller to measure? Because all the things are automated now, right? So it should have an automated controller which should be informing or displaying the person about the pressure that it is exerting in a second's time, because it's all very huge things that is available. So why is it not happening? Why the person who is in duty can be able to monitor? Or if it is a complete automated system, why the system is not able to understand that the pressure is getting more and more, right? So there are a lot of instances. So where in such cases, in such kind of automation system, it's not the human who is going to generate data. but it is the machine which is going to give you the data. Similar to that, lot of sensors. Now people are talking about the smart home, okay, and smart home, smart chair for elderly people. What the smart chair will do, when the elderly people is being seated on the chair, given with lot of sensors, okay, which is touching him continuously, it will try to pass in the data, right? So about his pressure, the number of pulse, and so many different parameters that we are in need of, the temperature of the body, all those things are what we are in need of, right? So in that case, who is going to be the data generator? It's not a human being, it's a sensor. So anything in this world can generate your data. So if that is the case, even if the human being is able to miss out value, the sensor, it's obvious that you cannot have a complete data set, right? So the values will obviously be incomplete, okay? So that's the reason why we have missing value analysis as a perfect requirement, important requirement in your machine learning, right? So then you have scattered values, meaning that a particular, let's say even when we are talking about painting, if I have a 1,000 square feet home, okay, one painter may give you the quotation for 20,000. One other painter may give you a quotation for 80,000, right? It differs. The values are scattered in a wide range, okay? You don't have a control over it, okay? So always when the data collection is left to people or sensors or any hardware device, it's a fact that the values will be scattered, and you need to again work on it to bring it back to a standardized notation, okay? And presence of outlier, okay? What is an outlier? In a family, if I have 20%, okay, it's not that all 20% views have to be aligned in a single perspective, right? Simple perspective. 15 of us may be interested in having a low budget painting, okay, but 2 or 3 of us may be interested in a very high budget. 2 may not want the house to be painted at this pandemic, right? So the persons who are not aligning themselves to the common structure of the data set is what we call as your outlier, okay? So the presence of outlier is always a problem, right? So if you are, since all our professors or even students, it is like in a class of 60, okay, it's an obvious fact that 2 doesn't need to learn at all, okay? So they will always sit at the last bench. And 5 or 6 or 10 of these 60 students may be over intelligent, okay? As a teacher, our intention would be to have an average overview of all the audience. That's it. That's the problem for me also today. For everyone, that's the issue, right? So we'll be trying to cover up the entire audience that we have at our hand. So the intelligent person, we cannot convince them. The person who doesn't want to listen, who is joining by compulsion, we cannot convince them. So these are what we call as the outliers in the data set, okay? So having them is a biggest problem. So you have to identify and remove it, okay? And presence of categorical data, right? What is a categorical data? Actually in your data set, in all the columns, we have 2 types of data. One we call it as your numerical data or continuous data, and the other thing is called as your categorical data. The numerical data is like, continuous data is like, 1 minute, we have seen scattered values, outlier, yeah. So continuous value, if you take, if 100 instances are there, let's say, if the values or attributes are all continuous, that is, you cannot fit into a finite number of class labels, then we say the data is continuous, okay? For example, the marks of a student, okay? We know the range. The marks will range between 0 to 100, but you cannot say that the mark should be like 5, 10 in multiples of 10. Likewise, we cannot say, right? So it is continuous in a particular range. Then coming to categorical data, it's contrast, right? So earlier we have the marking system. This nowadays the students are not getting individual marks, rather the marks are mapped to grades. If that is so, whatever be the marks, even if it is 90 or 99, so the student's grade is going to be yes, okay? So you have finite number of class labels attached. What are those class labels? S, A, B and so on up to E according to the university norms that we have. So if the data is of that kind, we say it is categorical data. Since we are going to work with the machine, we know that numerical data only can be processed and categorical data needs to be converted into numerical data. Okay, so the concept that we follow is what we call as one-hot encoding, mapping one-to-one value, right? A could be mapped to 90, B could be mapped to 80. Likewise, you can map. But the problem now here is whether it is correct, because a student may have secured 99 and may be awarded with yes, but when you go for one hot encoding, you'll be mapping with the number 90. Okay, so that's one optimization that we have. Then we have feature scaling. This is not what we are going to cover today. Actually, it is like the number of features that you are going to consider for further processing. Okay, so if I have 10 features listed, it's not that all the 10 needs to be used. Okay, one or the other can be left out, because for example, generally we used to store a column called id, right, which can run in sequence numbers, storing what is the id of the person or the number of person who has given the entry. Okay, so when that is brought in, it's not of use for us to understand the relationship, and hence it can be removed. Okay, so these are some of the pre-processing. So these are a necessary or this may give you an insight of having pre-processing attached to our data set. Okay, so once this pre-processing is done, okay, now the data set, lot of pre-processing are there. It's only the pre-processing that can give you an improvement in the result. Okay, now we have hyperparameters also, that's all there in modeling, but generally if proper pre-processing is done, then we say then that is the result of the modeling would be okay. So now and having understood the necessity of pre-processing, coming to the different phases in ML modeling, right? So what are the different phases that we need to have in machine learning modeling, right? You have the data set now, then you are going to pre-process it, right? This data set goes into the next phase called pre-processing. Yeah, now I have pre-processed, then you can use any machine learning model, okay? So, and train the system, arrive at a model, that is the next step. Once this model is got, okay, what you can do, this model can be used to give output for the new data values that is coming in. Okay, for example, if I'm doing the painting prediction, okay, for n number of houses, if I'm adding the experience, if a new person comes into me for the next time, given all the input values, I can very well say that how much is the cost that may be incurred for that. Okay, so that is one kind of way. So what to do with this modeling? Having modeling alone is enough? No. Okay, so this result of the modeling has to be analyzed. Okay, you have to analyze it well in different patterns to understand whether the results convey what you actually require, right? So then it goes to a phase called testing, wherein we'll try to test it with some other data set which doesn't correspond to your input. Okay, so input that is training data set, and then we'll try to validate your results. Okay, finally once it is done, you can deploy it to your client side. So these are all the phases in ML modeling. And what's required to proceed with ML? Okay, now that I hope you can understand, you would have understood what a data set means, why the pre-processing needs to be done, and what are the different phases that is associated with ML, right? So what's required to proceed further? Okay, so you should have a data set. If somebody tells that I don't have a data, you don't have business with him. Okay, that's it. It's ruled out at that point. Data set is a must to proceed with ML. Okay, so I have chosen Python as my platform and Jupyter Notebook as my platform, but there are hundreds of platforms which you can use. Java gives you the same set of features with rich in Python packages. One advantage of using machine learning with Java is deployment of finally whatever we create is not at all useful to the client, right? You have to give an UI where they enter the value, it has to give you the output, right? So in that way, Java gives you sophistication to map your processed ML models to a output UI. Okay, so Python also supports, but you have to work a little bit to map. Okay, so you have to have a Jupyter Notebook installed on your system or an online environment called Google Colab, which we'll shortly see. And Python programming, knowledge of Python programming, it's preferable. right? And you should know minimal statistics, not in much in detail, like mean, what is standard deviation, variance, all those things will continuously come, so we should not be in a position to avoid that. So that is the knowledge, right? But if you have a knowledge of all these things, that's all. It is very simple. You can proceed with ML. So this is my last theory slide. We'll go on for implementation thereafter. So in machine learning, we have two basic category for algorithm, right? Because all the pre-processing we have done. Now that you have Jupyter, assume you have Google Colab. Our next intention is to model, right? How to model? We are in need of the algorithms, right? What are the different categories of algorithms we have? Machine learning supports two basic categories of algorithm. One is supervised, another one is unsupervised. Okay. How? What is the difference? Okay. So you just have a look at this Excel sheet, right? So if you download any data set from any repository, you have a look at it, find out whether there is any column that is just which is dependent on other column. For example, here if you look at, we can very well understand the fact that cost is a value which will be calculated from other attributes. Okay, all other may stand alone, but this cost is actually dependent on other attributes, right? So if that is the case, we say this has to be the output variable, because we are interested only in this cost. So if your data sets pertain to this corresponding format, having n number of input attribute, okay, or independent attribute, and one or more dependent attributes, we say it comes under supervised data set. Okay, if I remove it, okay, assume that I am removing this column, what will happen? You have a data set. What can you do? It is not permitted to compute anything. Rather, you can do some kind of work. You can cluster based on how many are requiring for same color. Okay, how many are representing the size to fall within 14,000. Likewise, some kind of clustering you can do. That is the only operation that you can do, right? So, and hence, the class of machine learning algorithm falls into two categories: supervised and unsupervised. Supervised is having a teacher, that is having an output column. Right? You have set of independent attributes called input attribute, followed by one output attribute called your dependent attribute. Okay. The other case is called as your unsupervised learning. Unsupervised learning, as we have seen, it doesn't have any output column. Okay, what is the operation that you can do is only clustering. You can just group based on some or other attribute having it as an impact. That's all. Okay. In supervised, since we have the output column, based on the type of value you have in your output column, we have two kinds of algorithms again: classification and regression. Okay, if the value that you have in your output column is continuous, okay, then how to find whether it is continuous or not? Okay, so as we already have discussed, okay, so you have a look at this. If it has finite number of values, then we say it is categorical, otherwise it is continuous, right? So normally, even if you say if I have 15 number of instances, 15 different values may be assumed to be a categorical value. Somebody may claim like that. Doesn't mean that. Okay, if you give a new entry as over here, okay, whether you want any of these values to be fitted in, or you want any values within this range to be computed as an output, makes the difference, right? So accordingly, we have two categories. One is classification. If your output is categorical, if you have finite set of labels, it is classification. If you have continuous values, it is regression, right? So this is about your theory. Now we'll move on for the practical session to understand how I took the same data set, painting data set, which I have shown you here, and then I have worked out it, computing the cost as the output column, right? So I have applied. So since cost is your output column, it has continuous values, and hence regression is the concept that we are going to use. I'm going to use linear regression today. Okay. So now this is your Jupyter notebook. Okay. So to install this, you have to install Either Python with additional libraries, or straight away we have a wrapper called Anaconda. So Anaconda comes up with all the packages installed. Okay, so if you install Anaconda, automatically Jupyter Notebook will come part of it. So the biggest advantage of Jupyter Notebook rather than IDLE is it has individual cells. You can create n number of individual cells. Okay, the benefit again to have like this is you can execute only part of the cells. It's not necessary to execute all the cells continuously together. Okay, you can break. If I don't want to execute cell 3, you can leave it. And the other advantage is somewhere in the middle you can see here. Okay, I have given a comment. Okay, so this is what we call as the markdown cell or the text cell. Okay, so you can write any kind of instruction that you want. Okay, for example, here in order to make it as an header, I have given the hash. I can write. So this is a block. It will just be available as a text. So it has the combination of both text and code. So you'll feel the comfortness in doing so, right? So again, if you don't have this kind of provision, I can't install. What can I do? Google comes up with the support, right? So you can use Google Colab. It is a collab that is cooperative so Google Colab is a cooperative laboratory available given by Google in order to utilize their infrastructure. Okay, so this is a cloud-based environment where whatever you execute here will be executed on the servers that is running on Google, and you'll be given with the result. Okay, so I prefer using this when you have comfortable internet connection, but confidential data is not supposed to be entered here because it will be used by all. Okay, so again the environment looks like the same. It will be like a Jupyter Notebook. The only difference is here, for the files to be imported from your local drive first you have to import it onto this Google Colab, and then you have to import. Okay, I have just showed before that. We'll look at this here and then we'll come back. Now, looking at the different libraries that I have imported for today, NumPy is a numerical Python library available for performing numerical operations. Then I am using PyPlot and Seaborn, which is a library available for visualization. I am using one more important library package called Pandas. Let me give you an overview on Pandas. Pandas is just a library or a package that is available to work with DataFrame. A data frame is nothing but a two-dimensional matrix. Okay, since all your machine learning algorithm runs only on two-dimensional matrices, a special library is created called Pandas. You can do all sort of operations like adding two matrices together, computing its inverse. Okay, so arriving at the product of two matrices in just a single statement using the Pandas. It's very comfortable for accessing, right? So PyPlot and Seaborn is for visualization, right? So if you we don't have time in explaining this, and hence I am just showing the Seaborn library alone, and then we'll go on for this exploration of dataset. Okay, so this is just a simple IPython file I have created to exhibit the effectiveness of Seaborn. So I have imported one data set called flights, okay, which is having, if you look at, this is the type of data that it has, year, the month, and the number of passengers traveled in the corresponding flight. Okay, so you see this is a graph we have drawn using PyPlot. It is a scatter chart between the year and the number of passengers traveled. The same diagram we have drawn using your Seaborn. You see how good it is visually, okay, and hence is the advantage of your Seaborn. Here what is this is the hue. Hue is how do you want to visualize, what is the attribute that on the basis of what you need to visualize, okay. And then you can have, this is this is a very important graph that people were talking about, which is nothing but a heat map. Okay, it is very simple. So you look at the data. I'll show you the data of what I did. Okay, this is the data we have. Okay, what this heat map does, it will try to identify the minimum and the maximum value among the values of your matrix, and it will try to plot, give the coloring, right? 0 will always be marked with black, and the maximum value, what is maximum over here? It is 3. It will be marked with white, and your color will get distributed from here black to white, okay, based on that. Here red is actually used as a hue. You can even use green or blue according to your requirement. And you see between that the same values will be given the same color. 2 and 2, you see it is given same color. 1 and 1 you can see. So visually you can have an impact. You can get to have an impact of which values get repeated of how many times. Here if you look at itself, we can able to understand 0 is recurring more and 3 is recurring very minimal. So that is a heat map, right? Similarly, we have, this is the box plot. Okay, so you look at the box plot, it's very comfortable to understand the outliers, right? So what is an outlier? This box plot will tell you what is the range of values. Okay, so where that is commonly distributed. What is the range of values where the data points are commonly distributed? This is the deviation, standard deviation from the mean. Okay, so the mean of the values will be calculated, and this is the standard deviation. These we call it as the outliers, these two data, which doesn't fall under a particular standard deviation. Normally we used to, if we want to give relative grading, this is the concept we do. You can take out this outliers and say they have achieved this much of grade. Okay. Likewise, this is a very simple and a very important graph which can be used to compute your outliers. See, this is a pair plot, right? Suppose if I want to know how one attribute is impacting on the other. Okay, we may be heard of about correlation, right? So what is correlation? It is the impact of one variable over the other. If there is a unit increase in X, whether there is an increase or decrease in Y can be understood by the correlation, right? As you move towards X direction, if on your Y direction, if there is either a constant increase or a constant decrease, we say it is positively. So the correlation, if you see here, when there is an increase in X direction, what X represents, it is the total bill. Okay, it is for a hotel data set. As the total bill increases, we can see an increase in the tip. Okay, so this is positive correlation. Okay, if on the reverse side, if you want to plot what is negative correlation, when there is an increase in X, when the total bill gets increased, if you don't want the tip to be given, okay, so you will have a graph running from top left corner to bottom right corner, in which case we say it is negatively correlated. If you couldn't find any relation, okay, somebody may give the tip even will is good or bad, somebody may leave. Okay, so if that is the case, we say it is no correlation. Okay, all those things can be easily visualized using this pair plot. Okay, now this is the correlation value. How to find? It's very simple. The Panda supports one function called .corr. Okay, so this is the method to find the correlation. I have find the correlation and stored it in an array df3. Again, if we plot the heat map with the values printed on it, you can see always the correlation value ranges from -1 to 1. Right, so all these things are positively correlated. That is, when I plot itself, you can see all the things are either vertical, horizontal, or from bottom left to top right. So no negative correlation. So all are positive correlation. Again, heat map is again simple. It will take the minimum value, which is 0.5 in this case, and it will plot it to black. 1 is the maximum value, plot it to white, and then it can move across varying the colors depending on the values between this range. Okay, and you can see this is the heat map that is generated. So many different type of graphs you can draw using Seaborn, but these are all the common plots that we will be using. Okay, coming back to the data set which we have taken for consideration. Now, this is a method used to read your CSV file onto the system, right? Painting.csv is what we have stored, okay? And this is what read CSV is a method used to read the file onto the data frame, and we are creating a data frame, right? So, we'll use the function called shape to find out what is the number of rows and number of columns. 15 number of rows and 9 number of columns is there in the data set, okay? What are the headers that it has? You can be printed using df.columns. You can see brand, all those things which I have created on the data set can be given here. Okay, so I may have a doubt of whether the data have been imported correctly or not. For that, I am printing the first 5 rows. df.headof will give you the first 5 rows. If you want to print first 7 rows, you can do by passing a parameter. Okay, if you execute, you can have 7 rows over here. Okay, likewise you can do. And then you have one important command called describe of, which can give you the entire data about your data set. Okay, you can see the count. Okay, how many values are present in this count? You can see one variable has 15, another variable has 14, another variable has 11. Why? Because we understood that there are some missing value. You can see in this type all are present. In what is it, number of days something are missing. Okay, and hence accordingly you have number of values that are present, and the mean of that has been calculated, standard deviation is calculated, minimum value, maximum value is calculated, and you have 25% deviation from the mean, 50%, 70% has been calculated, and it is in this describe function will give you all those things. Right, you make a note of it. This function is not returning these set of values for all how many columns do we have now? We have around some 9 columns, right? But it is giving only for 5 columns. Why? Because all these can be created or calculated only for numeric values. Okay, so some of the values in our data set, these are all categorical values. See, it has only many and same. This is categorical, this is categorical, and then if you look at this is categorical again because it has 1 2 3 E and I, it is sorry, this is numerical also. You can take this brand and ext are all categorical. So and hence these values will not be taken for that description. Right, so once having done that, the first pre-processing activity we are going to do is missing value analysis. Okay, so how to find? df.isNullOf will tell you whether there are any values. .SumOf I have used to find how many number of missing values are there in each and every column. Okay, you can see this brand, type, and then 3 more. Okay, doesn't have all the values filled up, but there are some columns with missing values. So and hence I am going to fill it. Okay, so missing values filling up, again you can fill up with anything. Today I have shown you different ways where I have filled. I am going to fill the size of the house, okay, attribute with its mean, because there is no point in putting it as 0 or 1, right? It is just representing the size of the home. So I am going to take the mean value of it. Okay, and I am going to fill it with fill the null values with the mean column. So the command that is available for that is fill NA. Okay, so you can see after having done that, the size column, no, you could not see, that is you won't see any null values in that I have printed. Again, df.isNullOfSum, you can see the size doesn't have any null value. It would have been filled up with the mean of that column. Okay, then again the number of days. Okay, so number of days, what I did, I tried to fill the particular column with the maximum days. Okay, because there is no point in taking an average. So what I have decided, it's all one's own perception, right? So what I have decided, so I may take the maximum days that somebody has given and may want to print. Okay, so that column I have filled using max. So in order to find whether it is filled properly, the days, if you see, it is 0. Okay, the number of missing values is 0, and hence it is done. Now exterior or interior. Okay, I am going to fill it with a fixed value called I, interior. Okay, for all those who haven't given their option, I am going to give the value as I, and hence this is a fixed value fill up. Okay, similarly for color, I am giving the same as the option, single color. That is what I am going to use. Okay, having done so, now you can see there is no missing value available. The entire data set has been filled. Now let us try to visualize. Okay, so I have given simple visualization today. I have created a scatter chart between size and then the cost. Okay, so in Python everything is very simple. It may look pretty, but the concept is very simple. Okay, the title of the chart, okay, and then with x label of x axis, label of y axis, and then scatter chart is what I am going to draw. Between what values? X value has to be given, df of size. Okay, what is df? It is nothing but the data frame we have created. the name of the column is size. Okay, and what we need in y column or y attribute, it is df of cast. Okay, so that is what we have done. And I have extended the same diagram to accommodate two different what to say, the attributes. Okay, so we have drawn the graph between size and cost. Now in the same graph we are going to draw a scatter plot between size and days. Okay, so that's what I did here. You can see so this green dots represent A is nothing but between day size and cost. This blue dot represents your days, number of days you are in need of, size and then the number of days. Okay, why is it aligned on the same row? Because the days, if you see, it is ranging from some 21 to 30. Okay, but the cost, if you see, it is ranging in a very high value, right? So we cannot, the system can't create such a very big plot representing all those things, and hence it is all aligned on the same grid. Okay, so that's the reason for that. Then we go for one hot encoding. Okay, the next step is to convert all your categorical values into your numerical values. Okay, how to do that? So what I am going to do is, for every categorical value, every attribute having a categorical value, first we need to identify what are the unique values it has. Let's take brand, the values are A, B, C, D and E. Okay, everything we have to map to a individual value. That's up to you of how you do. Okay, so there is a separate concept in software engineering called scales of measurement. Okay, so the scales of measurement means in what scale are you going to measure. So I'll tell you just a glimpse, but it's one kind of thing is nominal values, right? One kind of filling up your attributes is nominal. Nominal in the sense, if I give male as female under the sex attribute, okay, these are nominal values. Male cannot be related to female. Female cannot be related to male. If you include others at a category, those cannot be related to these two, right? So if all the class labels stand separate without relationship to each other, we say it is nominal. Okay, ordinal, let's say if the feedback of this session is going to be collected from all of you. Okay, so it may be in a range, right? So low, very low, fair, good, very good. Okay, there is a relationship between these attributes. So that is what we call as your ordinal. So depending on what kind of data you have on this column, you have to accordingly encode it. Okay, so now if you look at this brand, it's all nominal value. Nippon Paint is nowhere connected to any other paint. Okay, so that stands separate, the brand B stands separate, and hence you can go for one hot encoding, right? So how to do that encoding, we'll see. See, now in the different variable, we are going to create the unique values for all the different attributes. df of brand dot unique of will tell you what are the different values that are there available. Okay, now I am creating A, B, C, D, one mapping. This is a dictionary. Okay, those who know Python can understand that this is a simple dictionary. A has to be mapped to 0, B has to be mapped to 1, and accordingly you can map it to till 4. Okay, so finally we are going to replace the column brand with this target classes. What happens? It will go to this attribute, find out where and all A is there, replace it with 0. Okay, you can see here brand will take numerical values now instead of your categorical values, right? Similar way we are doing it for ext/int. What is exterior, interior? Again we have two nominal values, so 0 and 1 could be our replacement. Okay, that we did, and you can see 0 as 1 as your value, and then target classes. Okay, so what are the target classes we have? Many and same. What are the color? Okay, so preference, one or many. We have many and same. That also we have replaced with the values like 0 or 1, and you can see similar to that. The next why I have commented is I already have executed. Now it will go and check for color change. If it is not there, it will tell you an error. That's why I commented. Okay, so now if I execute, you can see all the values are now having your numerical values, not your categorical values. Now it is ready for data modeling, right? So now again the next concept we are going to do is normalization. Okay, why normalization? We already have seen a concept that the data values may be scattered. Okay, somewhere we have drawn the diagram now. In the plot itself you can see. Okay, one attribute is ranging from 2 lakhs to some lakhs, and the other attribute ranges from this. Okay, so the range of values that we have is not normalized, and hence we may be having a problem in visualizing. Okay, so how to avoid that? A concept is there called your normalization. So before normalization, here as usual, as I have told you in Seaborn, I have found the correlation value. Okay, in order to understand how the values are related to each other. So this correlation is what we have computed values, and then I have drawn a heat map. Okay, you see the values ranges from minus 0.4 to 1. Okay, so the minimal value take black color, maximum value take 1. Here this 1 is on the diagonal, it is between that and the same. Okay, and hence we don't need to bother. Otherwise the maximum value that is available here on the positive side or on the positive correlation is, what is the value? If anybody can able to see, I guess it is 0.42. Okay, so and the minimum value that is available is minus 0.4. So what does it convey? The positive value, when it is between 0.5 to 1, we say it is highly, that is, it is a best positive correlation. Okay, when it is between minus 1 to minus 0.5, it is a best negative correlation. Anything in between these two, we say it is not properly correlated, and hence linear regression may give you improper, that is not much more accurate result, and hence go for concepts like your perceptron. Okay, so that's the way we can understand. But ma'am, Bhavadharani ma'am, can I go for 5 to 10 minutes more? That's the understanding from this. Okay, but today I have executed linear regression alone. I'm not bothering about your accuracy value, but this is for your information. This kind of information you can infer from the heat map. Okay, and then this is just to show you how to drop the features. Okay, for example, if I say that the number of persons that can paint on a particular day is not of our interest, you can drop it by using the simple command called drop. Okay, initially we have 9 features. Now when you drop, it will get reduced to 8. Okay, then I am going to split the entire data set into input data set and the output data set, because altogether it stands on a single data frame. So this train X will have all your training X features. X refers to your independent input attributes. Okay, so what is an independent input attribute? It is all these values except this number of persons which we have dropped. Okay, 0, 1, 2, 3, 4, 5 and 6. Okay, so we know in Python the last value will not be taken, the processing will stop before this last value. So 0 to 6 columns will be segregated and it will be stored in train X. Okay, so and hence the indexing, how if I print the shape, okay, you have 15 rows and 7 columns, right? Totally it has 8 column. Now it has 7 column as input column and 15 comma, that is means one attribute. Okay, so that the last column was divided as train underscore y, which is the output variable. Okay, now we performed normalization. Generally the normalization will be performed on input variables, not on the output variable. So in sklearn library, all are available at our hands using a single function. So the beginners can very well use this library. If your intention or a researcher wants to make any changes on the usage of the algorithm, then we can hard code it. Otherwise this is enough and easy. So I am including min-max normalization, a very simple normalization concept. X minus minimum divided by maximum minus minimum. Maximum minus minimum is the range in which the data is populated. So how much your value is deviated from mean. Okay, the ratio between these two we call it as min-max scale or normalization. Otherwise, if you want to simply go for a normal normalization, like x is equal to x divided by max, or x divided by min. Any normalization, whatever you want to apply, you can apply. Our intention is to bring in all the values only on the certain range without disturbing their proportion. Okay, that is the only thing. So here, once this normalization is done, okay, again I have plotted the graph. I'll just remove this and show you. So this is the after graph that we get after normalization. So this should be changed to days. You adjust. So here it is like, if you see between the size of the home, which ranges from 14,000 to around some 15,000 something, the number of days required for painting is distributed like this. Okay, so you can have a better visualization. That's what. And this is the pair plot we have drawn. Okay, so in pair plot you can very well understand. See, you look at this. This is negative correlation. Okay, this particular entry, negative correlation on certain entries. You see this. It starts, that is, you can draw a optimal line from top left to bottom right. Okay, if that is the case, it is negative correlation. Otherwise, if it is from this data, if you see, you can draw a line from this bottom left corner to top right. Okay, if that is the case, it is, you see this is a example for positive correlation. Okay, as you increase the value of x, y also increases. Okay, so you can draw an optimal line fitting this corresponding direction, and hence this is positive correlation. And hence, if you look at the correlation values, you should see a positive value over that. Okay, it will definitely be there. And this is about pair plot. Then again, I have drawn one box plot also. Okay, so this box plot we show there are outliers. Actually, Z score is one another metric used for outlier identification. Statistically, you can see this is the mean here, but this is also one way you can visually understand whether the present outliers are there available in the data or not. Okay, so these are the outliers. When outliers are identified, it's up to us to either remove the corresponding entity. If we feel like some students are not at all ready to study. See, slow learners is different, but if a student is not at all interested and if he is continuously scoring only 0 marks for 10 times, it's better to make him sit at home trying to concentrate on his own area of interest. So removal is also one another characteristic that we can do. Once having done all those things, I have created a linear regression model for this. If from sklearn we are importing one object called linear model. So linear model has linear regression as well as logistic regression. Some other models it has. Linear regression is a method that we have imported. We are going to fit a line. Okay, what is linear regression? It is simple as that. You have two attributes, let's say y is equal to x and y. X is an independent value, y is a dependent value. We'll be trying to fit a regression line, y is equal to mx plus c, trying to optimize and going through all the values. Okay, it's obvious that there will be an error. Okay, so the line which you are drawing will not touch all the points on space. The deviation between the line point and the actual requirement is what we call as the error. Okay, the points input between the line has to be plotted between your input points and the output. The coefficient, see, if you have multiple input values, here we have around 7 input parameters. So x1, x2 and so on up to x7. So we'll have 7 coefficients, m1, x1. So the line will be modeled like y is equal to m1, x1 plus m2, x2 and so on up to m7, x7 plus your intercept. The intercept is nothing but the common bias that is prevailing on the data set. Okay. For example, if all the values start at only 30, okay, we say 30 is the intercept. Okay, so if that doesn't have any y values, when x is equal to 0, if all the values are aligned above 30, then we say 30 is the bias or the intercept. That is that. Okay, once having done that, now we are going to test the system. How to test it? Regress.predict of. So here today I haven't splitted the data set into training and testing data set. Yes, you can do 80-20%. Since the data set is very low, I am going to train the system with all the 15 rows and I am going to test the system also with all the 15 rows for the same data set. That's what I did today. So regress.predict of, the same input values what I passed. The values, predicted values are stored in y underscore predicted. Okay, so I just have plotted, you can see 20,000 is the first value. Okay, you can see in the data set. So what is the first value? That is actual value 20,000. But our system has predicted it to be 2,13,230. Actually 2 lakh is the actual value. Here it is 2,13,230. So the difference between this predicted output and your actual output is what we call as the error. Okay, this is the error for one instance. Similarly, for all the 15 instances, if you write all the predicted values over here, find the difference, and the cumulative of the difference is what we call as the total cost. Cost is nothing but the associated error in the system. Okay. So we have different metrics to assess this. Actually, this is another 3D plot, okay, to show how the values are plotted. Coming to the metrics, okay, so metrics we say mean absolute error. Mean absolute error is nothing but the difference between the average of the difference between your actual value and your predicted value. Okay, actually if you do like so, sign will be of interest, right? Your actual values, if it is more than your predicted value, or if your predicted value is more than your actual value, you will have plus and minus sign that is occurring. So we are not interested in that sign, rather we are interested only in the absolute difference. Okay, so if you square it, that sign will go off, and hence came the next metric called MSE, mean squared error. Okay, so but mean squared error, if you see, already we have squared the magnitude. Okay, so and hence in order to bring it back, take the root, which is root mean squared error. Okay, if you do like so, you can come to know what is the values. Actually the value is much more. We haven't normalized your output column, and hence it is showing like this. Okay, some 27,174 is the error that it is root mean squared error it is showing. Generally the result of your linear regression is assessed by a score called R2 score. Okay, this R2 score, it shows the variation on your output based on the variation on your inputs. Okay, you have modeled a regressor line or a fitting line based on the variations on the input you have, right? So having done so, what is the variation that we see on the output can be given by your R2 score. Okay, the formula you can study from internet. Actually this is the concept. Okay, so it is giving 62.8% actually. So this is not a better R2 score, we should say. Anything between 25% to 30% is acceptable. This is indicates the fact that the data set has to be treated with much more pre-processing and has to be added on with much more instances, right? Since my intention is to create a data set, show how to process it for you, I have, because the data set size is very low. Okay, and all the values which I have shown here is all simulated from my side, and hence it's a fact that the errors will be much more. Okay, this is modeling, and once modeled, we came to know that these are all the errors that is available in the system. Since this much error is there, again we'll go back, improve our data set. Okay, again apply pre-processing, come back, do that. So that's what we call it as the iteration or the epochs. Okay, so these iterations will go on as long as you get a comfortable threshold value. Okay, for R2 square, let's say if I assume like 0.3 is okay for me, I can stop whenever I'm getting an R2 score. Okay, so that is what we call as analysis, the fourth phase of ML modeling. Okay, fifth phase is testing. Once done that, okay, now I trained only with the data set which I have created. Okay, how to test it with the general environment? You try to take inputs from people, calculate, then that becomes your this thing. Okay, finally the last thing is thing is deployment. Okay, how to deploy it? Okay, we have lot many tools in Python. For example, a Flask environment is there, where you can create a user interface, embed this package, and then you can come out with an output. Okay, hope I'm done with my presentation. So